Here's the process to find the zeros of any polynomial. Step 1. Using a graphing calculator, determine an easy spot for one of the x-intercepts. This is notes. That's your homework. That's your practice work. I'm doing the note sheet. Step 1. Use a graphing calculator to determine an easy in-spot x-intercept. Now, does everybody know what an x-intercept is? Shh. No. Does everybody know what an x-intercept is? It's where your graph crosses the x-axis, right? Okay. 2. Divide the original polynomial by that zero using synthetic division. Step 3. Repeat these steps until we reduce the polynomial to a quadratic. At which case, you guys know how to factor any quadratic, right? Any quadratic in the world, you guys know how to factor, right? Even ones with imaginary numbers. Because you can always use what? Shh. What are you doing?
I gave her a juice and she spilled it twice within 2 minutes.
All right, you can always use what? When in doubt, use quadratic formula. Note. You will find the same number of solutions. Now, solutions. Remember, that's what we call the zeros. Solutions, zeros, x-intercepts. All kinds of different names. So you guys have to be aware because I use all kinds of different names for our zeros, x-intercepts, roots, solutions, okay? These mean all the same thing. Shh, quiet. When I was teaching this to Mrs. Abruzzo class, I don't normally teach her class, but they were having all kinds, they were all confused because I kept saying the zeros, and they were used to solutions. Okay, so they kind of really didn't know what I was talking about. They all mean the same thing. Zero, solutions, x-intercepts, roots. Unfortunately, it depends on what concept you're in that we use the word. Okay, I use zeros an awful lot for x-intercepts. Now, the FTA, the fundamental theorem of algebra, states, it actually tells us how many roots are in every polynomial, or how many it can have. Okay? For instance, if I have x cubed, how many roots or for x cubed, how many zeros can I have? X cubed, x to the third. 3. I can have up to 3 roots or zeros. Okay? Now, another thing. When you're graphing these polynomials on the calculator to get a couple of the x-intercepts or zeros, because you're going to have to use synthetic division to get it all the way down to a quadratic to find the last 2 roots, the 2 utes. Sometimes the graph if I have an x and y axis, sometimes it seems to bounce off. It may look like it bounces off the axis. Sometimes there are two intercepts there. Okay? That means it's a multiplicity. If there's two roots or two zeros there, it means it has a multiplicity of 2. If there's 3 times it crosses the x-axis, then it has a multiplicity of 3. So you have to be careful there. All right, so let's look at some examples here. Numero uno. The f of x equals x cubed minus 4x squared plus 3x. And you have to find all the zeros. How many zeros are going to be in here? There's 3 zeros, correct. Now, anybody know how to factor a cube root? No. So, yes. The first thing we're going to do, because we're going to get this down to a quadratic so we can factor it, we're going to use synthetic division to get it down to a quadratic. What are my coefficients here? 1, -4, 3. What else?
0.
Thank you. 0. Don't forget we have a constant term there. Okay? They're in and graded. They've been in. They were done like I did them the hour right after this. Now, if you finished it later, I may have not had it. Okay. Shh. So, Jacob's right. We need to find one of the roots or one of the zeros or solutions. So, we're going to use our calculameters to find an x-intercept, a root, a zero, or a solution, however you want to call it. So, okay, x raised to the third minus 4x squared, squared, plus 3x, and we don't need to put the 0, but you will need the 0 there for synthetic division. Graph. Now, there looks to be a couple of solutions there that we can maybe figure out. Definitely looks like 0 may be a solution, right? I'm just going to double check. I'm going to calculate, use my second trace, the 0, right? Left bound, enter, right bound, enter, enter, and lo and behold, 0, 0 is a solution. So, I'm going to divide my polynomial by the solution 0. Okay. Guys, remember how to do this? Bring down the 1. 1 times 0 is 0, plus -4 is -4, times 0 is 0, plus 3 is 3, times 0, 0, 0. Right? Okay, so this becomes my x squared minus 4x plus 3. Easy peasy. I can easily factor this, right? Okay. So x minus 3 minus 1. So all of my zeros are what? x is going to equal 0, positive 1, and positive 3. There's all three of my zeros. Easy peasy, right? Oh my gosh. Yeah, we need to do a couple more examples. You have to be able to factor. That's why I tested you so many times on factoring. Hey, I'm here after school if you want help. I'm here every day until 4 o'clock, usually 4:30. Yes, Alana. Which, by the way, I'd say 25 to 30% of you owe me quizzes and have an F right now. So you need to come in after school or before school and take them. Number 2. 1, 1, let's see, would be 1, negative 1, 49, negative 49. Okay, I got to get something to divide it by, right? So, use your handy-dandy calculators. Putting in y equals, let's see, x raised to the 3 minus x squared plus 49x minus 49. Graph it. Eee. Well, I suppose I could mess with my window and get the whole graph in there, but also I need really is 1, 0, right? 1 x-intercept, and it looks to be like the number 1, but I'm going to check anyway. I'm going to find the 0. Left bound, enter. Right bound, enter. Enter. And it is indeed x equal 1. X equal 1 is one of my solutions. Okay. What? Okay, so hit second trace. You're finding the zeros to the polynomial. You're finding the zeros to the polynomial or solutions or roots or x-intercept, right? So I'm going to hit enter. Now, I'm going to do a left bound. Enter. I'm going to do, well, look where your x is, okay? Your x should be around 0.9 for your left bound, okay? Do you see your cursor now? Make sure your x is around 0.9. Because if it's less than 0.9, you're not going to see it on your screen. So get your x to somewhere around 0.9. So when you look for your x-intercepts, you got to make sure you have one in the negative side and one at the positive side for your bounds. Hit enter and then hit enter again. And one of my solutions is 1, 0 or 1. So I'm going to divide this thing by the number 1, which is one of the solutions, or zeros, or roots, or x-intercepts. You ready? What? Okay. Right. Okay, let me show you what's happening. Okay, this is what you have on your screen right now, right? It's worse. Okay. What is your x? What does your x value say right there? Okay, get that back to 0.9. So you're going to use your left arrow key and watch your number. Get it to about 0.9. 0.8, do you see your little cursor now? Do you? Okay, so at 0.8, you should see your cursor. Now, because every calculator, the cursor is going to be in a different spot. Okay, so hit enter. That's my left bound. That's my negative number. And then I want to get to the positive. You should only be able to hit the cursor once. It should go above the line. Right? Hit enter. And then hit enter again. That gives you the x-intercept, 1, 0, or the solution 1. It's what that means is it has a factor of x minus 1 equals 0. Okay, x equal 1. That's one of your solutions. If I were to factor, that's the whole thing that we're doing here, is we're factoring this. Oh, shoot. Uh-oh. That's what we're doing here, is we're factoring. This is a cube, so it's going to have 3 factors. Okay? We found one of them, x minus 1, or the solution x equal 1. So now I've got the x minus 1. I got to find the other 2. So now I'm going to use synthetic division. 1 times 1 is 1. Negative 1 plus 1 is 0. 0 times 1 is 0. 0 plus 49 is 49. 49 times 1 is positive 49. 49 plus or minus 49, 0. Now, you should get a 0 there. If you don't, you did something wrong. The reason why you get a 0 there is because we are dividing it by one of the solutions. Okay, so if you get a 0 there for your last one, if you don't get a 0, you did something wrong. Hey, what? Okay, so now my answer after I divide it by 1, well, this is my x squared, one less than what I started with, plus 0x plus 49. Or, in other words, it's x squared plus 49. Now, you may be thinking to yourselves, I cannot factor this. How? It is a perfect square. However, if you look at your flow chart that I gave you the other day, this is not a difference of squares. It's an addition. Okay? This is going to have imaginary solutions. Okay? So I'm going to have to solve this a different way. I'm going to set these equal to the zeros and solve it. X squared plus 49 equals 0. I'm going to subtract 49 from each side. Okay. I get x squared equals negative 49. How do I get rid of the power 2? Now remember, I can't square root negative numbers. This is where the I comes in, right? So I have x, yes. So I have x equals the square root of 49 times the square root of -1. So x equals plus or minus, actually there should be a plus or minus there, 7. What's the square root of -1 equal to? Huh? It's I. Okay? Yes. So, my three solutions are x equal 1 with what we started with, plus 7i, and minus 7i. There's my three zeros. Okay? So we're going to use a lot of stuff that we learned last semester and this semester to get these zeros. These are not easy problems. Okay, let's do another one. Number 3. This time I have x to the 4th. How many zeros do I have to find? 4 zeros this time. I have 4 solutions. Okay. Let's see, my coefficients. 1, 5, 5, -5, -6. Okay, I need at least 2 zeros, right? So I'm going to put it in my calculator. I have x to the 4th plus 5x cubed plus 5x squared minus 5x minus 6. I'm going to graph it. Okay, I'm going to get a couple of these. I'm going to see if that's a 1 there. So I'm going to hit second trace. I'm going to find a 0. I'm going to see what 0 this intercept is right there. Okay, so I'm going to do left bound, right bound, hit enter, and sure enough, I have a 1 here for one of my solutions. So I'm going to divide it by 1. What? What do you mean mine's not on the line? Your cursor? Did you do left bound, right bound? I'm going to go back and find another 0. So I'm going to hit second trace, 0. Got it? X equal 1. I'm going to find another 1. Left bound, right bound, enter, -1. So I found 2 zeros. +1 and -1. Okay. I'm going to use 1 first. 1 times 1 is 1. 1 plus 5 is 6. 6 times 1 is 6. 6 plus 5 is 11. 11 times 1 is 11. Plus a -5 is 6. 6 times 1 is 6. 6 plus a negative 6 is 0. And there's my 0. Okay? So I'm down to a cubic. I went from a quartic, now I have a cubic. So now I'm going to divide it again. I'm going to divide this again by the other 0 I found, negative 1. Bring down the 1. 1 times negative 1, negative 1 plus 6, 5. 5 times negative 1, negative 5 plus 11, 6. 6 times negative 1, negative 6. And here's my 0. Okay? So far I've got 2 of the 4 zeros. Now, this becomes x squared plus 5x plus 6. We could factor that, right? See, x, 2 times 3, and they add up to 5. So, my zeros for this problem, well, my 2 I found on the calculator, and then negative 2 and negative 3. There's my zeros. Zeros, just like Jacob. Do you want to try one of your homework problems? Are you guys good? No. I could. Yeah.